Hello and welcome to Algebra 2 tutorial. In this video, we are still looking at rational expressions and how math works with them, but now we're moving on to addition and subtraction. In the previous video, we looked at these three: multiplication, simplifying, and division. It's now time for the harder one: adding and subtracting. And if you remember back from elementary school, adding and subtracting fractions was definitely the harder one, so that's why we have a whole video dedicated to it. And so we're going to break this up a little bit for our adding and subtracting. We're going to take a look at the easy problems together, the mediums, and then the hard ones at the very end. We're going to break them up into those three chunks. So first, let's take a look at the easy types of problems for adding and subtracting rational expressions. So the reason why these are easy, as hopefully you can see, is that they have a common denominator. And that's one thing you need for adding and subtracting fractions. You need a common denominator. So once you have that common denominator, you just add across the tops. So 6x plus 12. Now those aren't like terms, so it just becomes 6x plus 12 divided by. Now the denominators, they don't change. It does stay the same. It's just x plus 2. All right, they don't add together, they don't combine. The denominator stays the same. And then we got to try to simplify this. Can we factor something and cancel something out? Looks like we can factor the top, so I'm going to pull out a 6. And then on the bottom we still have x plus 2, and yes, it looks like we can cancel out these factors here of x plus 2, and so we are just left with 6. So that's the easy type. Hopefully that wasn't too bad. When we have a common denominator, we can do our addition straight from the beginning. All right, let's move on to the medium type that are a little bit harder, but it is still the same idea. So here we have subtraction, and you can see we still have a common denominator. So we are simply going to subtract these two on the top. But because it's subtraction and I have a binomial here, I do have to distribute this negative. So the 12 becomes negative, and when this negative 70 becomes positive, and once I do that, I can add these. Another way, if you might want to see that, I'll put parentheses around this, and the negative does distribute. So the 12 is negative, the negative 70 is positive, and then we can add these together. So let's do that. If I add these together, the denominator stays the same, x minus 10. And then we combine the like terms. X squared doesn't have any like terms, so it stays. The negative 5 and the negative 12 are like terms, so we can combine those to make negative 17. And the positive 70 now doesn't have any like terms, so it has to stay as well. So we subtracted these. Now it's time to simplify. Can we do anything here? So what multiplies to be 70 and adds to be negative 17? I believe that is negative 10 and negative 7. So we factor the top. And the bottom is x minus 10. We can cancel those out, so yes, it does simplify, and our final answer is just x minus 7. So that one is very similar to the easy ones. The only difference is if you have subtraction, you do have to distribute that negative to the terms behind it, and then you add them and combine them just like usual. All right, so that's sort of the medium type of problem. Time for the hard one. Hopefully you can guess what will make these hard. It's the same thing that made these types of problems hard in elementary school. If you have no common denominator. So we have to get a common denominator before we can subtract these two rational expressions. And so to do that, to compare these two, we have to factor them. So I'm going to rewrite this expression, but I'm going to factor the terms. So there's nothing to factor with the 3 on top, but I can factor the bottom. So this denominator, we have multiplying to be 4 and adding to be 4. That is x plus 2 and x plus 2 minus. This next fraction, there's not much to factor there at all, so that one is going to stay the same. All right, now that we have things factored, we can compare the denominators. How do I make this denominator exactly the same as this one? Well, the second denominator needs extra stuff. It has one of the x plus 2's. It needs the second one. So I need to put another x plus 2 here. Now, I can't just put it in the bottom. That would change the math problem. So I have to put it in the top as well. So this fraction here, because the top and the bottom are the same, it technically cancels out. It's equal to 1, and multiplying by 1 doesn't actually change anything. So mathematically, I haven't changed this fraction at all, besides making it look different. Now I have common denominators. So I'm going to rewrite this a little bit, and we're going to actually get to subtract these. So the first one is not changing. So I've got x plus 2, x plus 2, minus, now the bottom is the same, so we have common denominators, x plus 2, x plus 2. The top, however, is now going to look different. So I'm going to take this 7 and distribute it. So we've got 7x plus 14. Now we've got two fractions that have common denominators. We're ready to start subtracting them. So just like our previous problem, we have to take this negative and distribute it. So this 7 will be negative, this 14 will be negative, and then we get to add them. So let's combine these. I'm going to start by putting my denominator because it's the same and it's easy. So x plus 2, that's not changing. And then combine the like terms on the top. So 3 combines with the negative 14 to make negative 11. And the negative 7x doesn't have a like term, so that stays without changing. So there's our answer. Now once you have your answer, you do want to try and simplify it. So is there anything we can do to simplify this? Well, we could try to factor the top, but we pretty quickly realize there's nothing to do there. So we have to leave it alone. So you could just circle that, but you can make this look a little bit nicer. Because the factors in the bottom are the same, you can write that as x plus 2 squared, I suppose. And on the top, they both have a negative in common, so if you really wanted to, you could factor out a negative 1. So that's 7x plus 11 now. That looks a little bit nicer. Not very necessary. We didn't actually simplify anything, just wrote it slightly differently. So if you don't have a common denominator, you want to factor first. It seems to be a common strategy we use. Factoring is never a bad idea almost. So we factored it, then we figured out what did one denominator need to look exactly like the other one, and then it becomes like all the other problems where you combine like terms and make sure your denominator stays the same. Alright, so that is what adding and subtracting can look like for rational expressions. Let me give you a few practice problems here to try out. Hopefully those make sense, and good luck.